All right, so we're going to get going on the second half of the 2.5 material that we started last Friday. So I believe we originally gone through the starting part here with PEMDAS, and we got through 2 examples here working with that in our order of operations. So we're going to continue on with these 2 examples here just to get a little bit of a refresher for this portion of things, and then we'll move on to the instances where we have fractions showing up, because I think these are the, admittedly at face value, significantly more difficult looking problems that we're going to have showing up. And I do want to give them their time that they do need, because there are ways to solve them. I want to go through that with you guys. But for now, we're going to work with our first set of examples, and we're going to start with example 3, and then we'll go to example 4 using PEMDAS in our order of operations. So I'll jump us over to the whiteboard, and then we will go from there. Okay. So again, working with our first clump of examples that we had there, those first 4, we're working with example number 3. Ooh, better 3. There we go. All right, so the first one I guess the first one, writing out example 3 for ourselves, we have 8 minus -4 5 times c squared. And we have that. Okay. Now again, there is a lot going on in this problem, and you do not want to rush your process as you are going through this. You want to keep your work neat, you want to keep your work organized, make sure you are keeping track of every last thing you're doing, and you are not rushing yourself or getting ahead of your steps. So again, following the method that I like using just to helps keep me organized as I'm going through this, I'm going to write out PEMDAS for myself, and then we'll start going through this step by step. So putting PEMDAS off to the side. Okay. So parentheses. I've got 3 sets of parentheses here. All I'm going to do is I'm going to look inside those and deal with them accordingly. So the first set of parentheses, I have 8 minus -4. I have double signs showing up right here. That is the cue, at least for me personally. I want to get rid of those double signs before I do anything else. I don't like having a minus and negative. It's complicated. So all I'm going to do with the first set of parentheses is I'm just going to get rid of those double signs. A negative and a negative makes a positive. Looking at the second set of parentheses, I have 5 minus 3 squared. Remember, we are inside that set of parentheses. We restart PEMDAS all over again, which means I'm going to be working with exponents first. The base of this exponent that I have, this little 2, the base is just the 3, does not include the sign. So I'm applying the exponent. I'm going to get 5 minus 9, so 3 squared there. And then in my last set of parentheses, I have -1 minus 7. Combine those together, and I'm going to get -8. So from here, I still have stuff I can do inside my sets of parentheses. Looking inside my first one, I'm seeing, okay, I have 8 plus 4, I can work with that. The second one, I have 5 minus 9, I can work with that. So again, I'm still just working inside the parentheses at this point. I haven't moved anywhere beyond that in PEMDAS. So 8 plus 4, give me 12. 5 minus 9 is going to give me -4. And then -8 at the very end. I couldn't do anything else to that, so it's just going to stay there as it is. Okay. So now from here, I'm looking at PEMDAS off to the side. I can't do anything else inside the parentheses. I have no exponents remaining, but I'm now at multiplication or division. I have 3 things multiplying together. I have 12 times -4 times -8. Again, by our associative property with multiplication, it does not matter which one we multiply together first. I'm going to like to do 12 and -4. So a positive 12 times a -4, positive times a negative is going to give me a negative answer. So we get the sign first. 12 times 4, 48. Negative 8's coming down because I haven't worked with it yet. And now I multiply these two together. I have a positive times a negative. Actually, I should say a negative times a negative, sorry. Which means my answer is going to be positive, so I work with the signs first. And I do 48 times 8. I don't know what that is off the top of my head, so I'm going to use a calculator for that. And I'm getting 384 in the calculator. And we have our final answer there. Nothing else I'm doing my other steps, so we're good on that front. Okay. So we'll take a look at the last example from that page. I do want to go through this one because this is there's a lot of subtle stuff that shows up with this one. Put that there. Okay. So we have the negative absolute value of 4 squared minus 7 squared plus 6 times the absolute value of 4 plus 1 squared. So I'm just going to go off to the side here. I'm writing PEMDAS for myself. And keeping track of where I'm at, what steps I'm doing. So I'm starting with parentheses, always. It's always our first thing we're doing. And we treat the absolute value sign as though it were a set of parentheses. It's always what we start with. So looking at our first set of parentheses that we have here. So I'm just looking inside. We're going to do the same thing over here. We're just going to work with our first set first. So I'm still going to keep the absolute value sign. The absolute value property does not apply if I do not have just a single number value inside of it. So everything simplified inside first before I can do the absolute value sign property. So I go inside a set of parentheses, restart PEMDAS all over again. So I'm just looking at 4 squared minus 7 squared. I'm saying I don't have parentheses there. I have exponents. I have 4 squared. It's going to give me 16. I have 7 squared. It's going to be 49. That's all I can do there. Inside the other absolute value sign, I have 4 plus 1 squared. 1 squared is just going to be 1. So I've taken care of the exponents there, and that's all I was doing in that step. Now, I still have things I can do inside these absolute value signs, which means I'm not done with parentheses yet. So I have 16 minus 49. If you need to apply your calculator for finding that, that's fine. 16 minus 49 is going to give me negative 33. And then for the other one, I have the absolute value 4 plus 1. That's going to give me 5. Write that in there. So now, within the absolute value signs, all I have is just a single value. And now only is the time that I can apply the absolute value property. So what is the absolute value of negative 33? Again, the absolute value tells us the distance we are from 0. So negative 33 is 33 units, we're going to call those. It's 33 units away from the from our origin, or from 0. Or you could think of it as all it's going to do is make that value inside a positive. So the absolute value of negative 33 is a positive 33. Better threes. There we go. Plus 6. The absolute value of 5 is 5. And now I'm completely done with all of my parentheses. So I'm done there. I can check that off. I do not have any exponents. Done there. I have multiplication going on. I have a negative times a 33, and I have 6 times 5 going on there. So we'll work with each of those. So a negative times a positive, negative is going to give us a negative 33. I have 6 times 5, that's going to give me a, I should put the negative in there, going to give me a positive 30. And now from here, combine these together, and I'm getting -3. Okay. And I'm looking to see, as I'm comparing the answers that we have here to what I have elsewhere, and did I do something wrong? Because we're getting -3 here, and my notes are saying something else. Ah. Okay, I found the error. So this is an error on my part. This 2 is supposed to be on the outside up here. So error on my part with that, but we'll leave this one as it is as we work through it. I have a couple others that are going to have similar properties to this showing up, so that one's on me, that part. But again, the process, we're going to follow the exact same methodology as we go through that there. If you want to go through and work with the correct setup, you just be taking care of that, putting the squared outside here, and then you'd find that this number is going to go to 25, and then we'll get some different numbers showing up there. So it doesn't change a whole lot, but that was the error that showed up with how I went through that. So yeah. Okay, I'm going to jump us back to our notes because I do want to go through the instances where we have fractions showing up with PEMDAS, and not just any fractions, kind of the more complicated ones with a lot of stuff going on with them. So we'll jump back to that, and we'll go through a couple examples with those. So those are absolutely worth seeing. All right, so working with weird or difficult looking fractions, you have a few ways you can go through and do the simplification process. I'll walk you guys through the 2 ways with at least our first example, and then beyond that, it's your guys' call on how you do or don't want to work with them moving forward. It's personal preference for the most part. So when you're working with those, you may simplify the numerator and then the denominator, and then simplify the resulting fraction in its entirety. Essentially, we take a look at this thing and say, okay, I don't want to work with this as one big, giant, single, gross-looking fraction, or I don't want to work with this as one big, giant, gross fraction, or this one. So what we're going to do is I'm going to say, all right, I'm just going to simplify the numerator. I'll just do that on its own. And then I'll look at the denominator, and I will just simplify that on its own. So then I'll have just a number up top, I'll have a number down below, and then I'll deal with the resulting overall fraction at that point in time. So you can work with it that way. You can follow PEMDAS using everything still as an overall big fraction. It's your choice. I'll show the 2 methods, both of those methods with this first example. But again, on future problems that you're working on the homework or on the test, you can use either method. I just want to give you guys multiple options at your disposal for going through and keeping your work organized. Again, I'm pretty indifferent on which one you guys would like to use, as long as it keeps your work organized and neat on that front. So we'll jump back to our whiteboard that we have here and work with our first example with fractions. All right, and clear this thing out. Okay, so our first example that we have with fractions. So we are told to simplify. So again, PEMDAS, order of operations that we're working with. So our first example that we have here, and again, these things are, this is a good gauge for what you're going to be seeing on the test. The examples that we went through today and on Friday also. So 5 squared. I've got that there. So first example, we've got 5 squared minus 5 times the quantity 9 plus 2, all being divided by 15 times -1 plus 3, the quantity -1 plus 3. And I'm checking now, and This time I wrote everything down correctly, so yay. So you have two ways you can go through and organize this. You can keep everything as a single fraction, or you can divide it up to the numerator and the denominator and work each of those separately. So I'm going to show you guys that method just for the sake of seeing it. So we're going to work with our numerator first. So all I'm doing is rewriting the numerator here. I'm going to simplify that on its own, and then I'll work with the denominator afterwards. So I'm following PEMDAS, but just for a portion of this thing. So I have parentheses. I have this 9 plus 2, so I'm working with that first. Everything else is staying the same. It's going to give me 11. I don't have anything else I can do inside my sets of parentheses, so I'm done with that. I have exponents. I have 5 squared. It's going to give me 25. And I'm now done with exponents. Multiplication or division, I have 5 times 11, or negative 5 times 11, I should say. Do not forget about this little negative out front here. Still applies. So I get negative 55. Done with multiplication division. I have addition subtraction. I've got 25 minus 55. That's going to give me a negative 30. See if my mental math is correct here with this. And again, with some of these numbers where they're a bit larger, no problem. Yeah, we get negative 30. So no problem with you guys wanting or needing to use a calculator for some of those larger number calculations. Nothing wrong with that whatsoever. So our numerator simplifies down to being just negative 30. So let's take a look now at our denominator. So again, just writing that in. And now using PEMDAS for that one as well. Looking inside my set of parentheses, I have negative 1 plus 3, so that's all I'm going to work with first. That's going to give me 2. So I'm done with parentheses. I have no exponents. I have multiplication or division. I'm multiplying these two things together, and I'm getting 30. I have no addition subtraction, so I'm done there. So I have my numerator value. I have my denominator value. Let's bring it all together. So my fraction is really negative 30 over 30. And now can I simplify this any further? I've got negative 30, negative divided by a positive, which means I'm going to have a negative answer. 30 divided by 30 is just 1. So my final answer is negative 1. Okay. So this is one method that you can use. This is if you want to split this thing up and work with each part of what we have here individually. If you're someone who isn't able to work through all of this systematically in your head, which is what we're going to go through here shortly, our process for that, all at once, I would highly recommend this process. Again, the two methods that we're going to go through, I'm going to go through keeping this all together here in a minute. It's your call on whichever one works for you. Whatever keeps your work organized and neat and gets you the right answer, I'm fine with. So I'm going to move us over here, and we'll go through an alternative method. Okay, so we'll keep everything. I'm just going to rewrite the problem over here, and we'll go through it using this other method. Again, I'm just going to detail out and show both of these with the first example. I'll use just one on the future problems we're going to go with. Let's move this guy over here. And we're going to find that as we're going through this, we're actually going to be basically doing the steps that we just did, except keeping everything together instead of splitting it apart. So again, I'm looking inside, following PEMDAS, do I have parentheses? And I do, so I'm going to work with just those first. So I'm going to have 5 squared minus 5, it's a very bad, weird looking 2 there. There we go. So 5 squared minus 5 times 11. And then we have 15 times 2. So my parentheses are now done. Working with exponents, I have 5 squared. It's going to give me 25. My parentheses are done, or my exponents are done, I should say. Then I'm looking at, do I have any multiplication or division going on? I have things that are multiplying together. So I'm going to work with those first. Oops. 25. Multiplying them. There we go. So multiplication or division, we just did 5 times 11, then 15 times 2. And then division. And this is the part where keeping everything together can get a little wonky, because as it's written, we have a couple ways we could write this out dividing for ourselves. We could split this into 2 fractions, 25 over 30 minus 55 over 30, and simplify it from there. Or we can combine the numerator together, the 25 minus 55, and then divide things out a bit more, which is another option that is at our disposal. The subtle part with fractions is also, if we were to rewrite this thing, we'd actually find that we would end up having to rewrite this as this guy here. So really, and again, it doesn't matter which way you want to write this out for yourself. Organization is kind of personal preference, as long as you have one that works for you. We're going to end up having negative 30 in our numerator spot one way or another. So if you want to do it with a fraction, if you want to do it this other way, as negative 30 here, we're going to get negative 1 either way. So again, multiple ways to go through, write this out, and organize it for yourself. I do not care which of these methods you would like to use on the homework or on the test. There technically are probably a lot more that I could show you guys, but I think that becomes a bit of an overload at that point in time. So when you're going through and working on these, if you want to use this method of keeping everything together as a single fraction, or maybe rewrite it as explicitly written as something divided by something else, you can do that. If you would like to split it apart into, I'm just going to solve the numerator, I'm just going to solve the denominator, and then bring them together and go from there, you can do that also. I am indifferent as to which methodology you would like to use for these problems. It's your choice. And I'm fine with whichever one. Just make sure you have your work neat and organized, and I can follow each of your steps as you're going through it. Okay? So we're going to jump to our second example that we have. This, or from this section. And I'm only going to go through these just because of time and whatnot. I'm only going to go through these with one method. So there we go. Okay, so our second example that we have with this, again, we're working with a fraction. So we have the absolute value of 4 minus 2 squared plus the quantity of 6 minus 8 squared. And then we have, for our denominator, and checking to make sure I have everything written down correctly because I messed that up on one of the earlier examples, and it's looking good. Okay, so for me, I like dividing this thing up into the numerator and the denominator. So that's the method that I am going to use to solve this out. Again, as you're going through these, you can use everything all at once. You can rewrite it as something divided by something else. It's your call. I just like to separating this out and doing it in smaller parts. Just my personal preference with it, but works for me. So again, following PEMDAS, so I'm writing this out for myself. And parentheses. Again, we treat the absolute value sign as though it were a set of parentheses. And then I explicitly have a set of parentheses in here, so fantastic. Whenever we go inside a set of parentheses, we restart PEMDAS all over again. So I'm working with the exponents first. So I'm working with 2 squared in that first set. In the second set, I don't have any parentheses, exponents, multiplication, or division. I just have addition, subtraction. So I'm going to get -2. Okay, I can still simplify inside the absolute value signs. I have 4 minus 4. That's going to give me 0. And now from here, the absolute value of 0, how far away from 0 is 0? Well, it's got no distance, so there's nothing that's there. So we can either write out 0 for ourselves if we want to, or get rid of it entirely. And from there, our only things we have left over is a -2 squared. So I'm done with parentheses. I have exponents, -2 squared. It's the same as saying -2 times -2, if you want to expand this out. And then we're going to get a +4 showing up. So look at the exponents, multiplication, division, no addition, subtraction. We're done there. So we have our numerator. The whole numerator simplifies down to just be 4. We'll take a look at the denominator now. So rewriting that out for myself. And then putting PEMDAS off to the side. So again, just following PEMDAS, same old, nothing's really changing. I'm looking inside the set of parentheses first. What I can do in there, I can multiply. So I'm getting 16 there, plus 10. I'm still not done inside that set of parentheses. I can do 12 minus 16. So it could be a -4. I've got a better 4. There we go. And now I'm done with parentheses. I don't have any exponents. I have multiplication or division though. I have 3 times -4. Positive times a negative is going to give me a negative. 3 times 4 is 12. Got that. Multiplication or division is done. Addition, subtraction, I have -12 plus 10. That's going to give me a -2. Done with that. So I have my denominator. And now let's bring these things together. My numerator is 4. My denominator is -2. 4 divided by -2, that's going to give me -2 for my final answer. And then we're done. So that was our second example that we went through. And again, if you're following through or following this and you're doing this on your own, you decided to use the other method that we have, you're more than welcome to do that. You should also be getting -2 as your final answer. So I'm going to jump us over to example 3. So pretty big, longer one that we have showing up here. So again, keeping your work organized, writing everything out is absolutely vital with this. Of course, you guys saw where I messed up on something earlier, so don't make my mistakes. I'm showing you guys what not to do in some of these regards, which is valuable in and of itself in some way. So a lot going on with this, so it's gonna make sure I have everything written down here correctly. Okay, so a lot going on here. And again, if you're someone who is looking at this and your first thought is, oh my gosh, this thing is a monster, it's tricky as all get out, say, yeah, it absolutely is. I 100% agree with you. But this is why I highly recommend, if you are trying to do all of this at once, you're going to have errors show up. So break it down to smaller parts and do it piece by piece. Makes life a heck of a lot easier when you're going through and solving this in parts versus everything at once. So again, I'm just going to work with the numerator first. So it's a lot of writing, I know. But it's better to have this stuff written out than trying to keep track of it all in your head. I've had people who, when I went through this problem, were saying, I can do this in my head. It's not a big deal. It's just a bunch of small parts going on. And look, if you're one of those people that can do that, great. I'm not one of those people that can do that. Okay, it's down here. So again, I'm going to work with PEMDAS, just telling you what to do. We're going to have a lot of steps with it, so don't rush yourself. Be very methodical with what you're doing. So sets of parentheses. I have a lot that are going on here. I've got this outer set of parentheses. I've got this one out here. And then I've got a set inside and an absolute value inside. So we're going inside of parentheses and then inside of parentheses yet again. So I'm just going to be looking at that there. And I'm just going to be looking at what's inside the absolute value. So that's the first thing I'm working with that. So we have the overall ones. 3 minus 10, give me negative 7, plus the absolute value of, and looking inside that, I have multiplication. I need to do that first. So we get that there. I can't do anything else to the negative 7, so it's just going to stay as it is. Plus the absolute value, that's the only thing I'm working with now. 2 minus 9 is going to give me a negative 7. And all that raised to the second power. So from here, I have simplified everything inside the absolute value sign. Now I just have a single value, and at this point in time, now is when I can apply the absolute value property and make that thing a positive. So everything is still inside a set of parentheses. This absolute value of negative 7 is just going to become a positive 7. And now I have inside my set of parentheses again, I still have a negative 7 plus 7. That's going to give me 0, second power. I'm now done with parentheses. I can apply exponents. 0 to the second power is just going to be 0. Done with that. No multiplication, division, no addition, subtraction. Done there. So I have my numerator. And now at this point in time, you might be thinking to yourself, well, okay, hold on. My numerator is 0. And 0 divided by anything is just going to be 0. And that is mostly true. I'll give you guys a second here to think of what, as I'm writing out the denominator, there is one thing that we cannot have in the denominator spot because we do not know the answer to it if we divide by it. So I'll let you think on that here for a second while I write this out, and then I'll let you know what that number is. Okay, so the one number that we cannot divide by because we don't know what the answer is going to be is 0. So if my numerator is 0 and my denominator is anything other than 0, great, I can have an answer. It's just going to be 0. But if I divide by 0, my answer is undefined, regardless of what the numerator is. So I still need to go through and check to see what is my denominator. So going through PEMDAS all over again with that. I'm just going to write this off to our side. Keep track of our steps. And again, if you're looking at this, thinking, oh my gosh, this is complicated, there's a lot that's going on here, there absolutely is. And this is the caliber of question you can expect to see on the test when this stuff comes up on it. Okay? So, and I almost wrote this one wrong also. There, and it's to the first power. There we go. Okay, now we've got it. All right, so starting with PEMDAS all over again, I'm looking inside my sets of parentheses, and that's all I'm going to work with first. I don't care about that division sign in the middle. So inside each set, working with the exponents, I have negative 1 to the first power. Well, 1 to the first power is just going to be 1. 6 to the second power, that's going to give me 36. And then 1 to the 14th power. Remember that raising something to a power means the base is multiplying by itself that many times. So 1 to the 14th. It is not going to be 14. The same as saying 1 times 1 times 1 times 1 times 1 times 1, and so on, 14 times. And 1 times 1 is just going to give me 1 when I do that. That big long list of ones that you could write out for yourself, it's just going to give us 1 there. Looking at our other set of parentheses, I have 5 squared. It's going to give me 25 minus 17. I'm still working inside the parentheses. I can still do stuff inside there. In our first set, I have negative 1 plus 36. That's going to give me 35. Plus 1, that's going to give me 36 again. So I'm going right back to what I started with. In the second set of parentheses, I've got 25 minus 17. If you need to use your calculator to get that figured out for yourself, you are welcome to. I'm getting 8 from that. So from here, I have 36 divided by 8. Can write that out for ourselves if we need to, or put that as a fraction. 36 divided by 8. Reduce that down. It's going to be 9 over 2. Okay. I'm getting a numerical answer out of this. So let's rewrite this thing. Let's bring it all together. So I have my numerator here. I have my denominator here. 0 divided by 9 over 2. So there's a couple things you can do with this. If we realize I have 0 divided by a number, we can just write this out as 0 and get our answer. You can alternatively write this out like this, as explicitly as division. We don't like dividing by a fraction, so we flip that second part and multiply. 0 times anything is just 0. So whether you get to that answer here or here, you're getting the same thing. Okay. So those are a few examples, the types of problems that we have, or we can be seen with the test when we are going through and using order of operations with a bunch of these different problems. And again, if you're looking at this going like, oh my gosh, there is so much going on with these things, there absolutely is. And I'm hoping it's hitting home the idea of keeping your work organized and going through and solving these things piece by piece. Because I don't know of anyone in any of the classes that I've had that can reliably go through and do all of these in their head or just all as a single fraction at one time. If you're one of those people who can do that, great. Good for you. You do not have to. I am not expecting you guys to be able to do all of this at once or in, let's say, 2 or 3 lines of work. It takes a lot. There's a lot going on here. So please cut yourself some slack if you're going through this and it's taking you a decent amount of time to go through one of these things. That's exactly why I assigned them, to force you guys to have to maybe take a bit more time to go through these and slow down in your process. Okay. So there's one more example on the lecture notes, and there are a whole bunch of group problems on the back. That's normally for the lecture stuff, but if you do want some other examples and some more challenging problems to go through, those are all available to you for you guys to download, view, and work with at your leisure. The answers are on there also. But otherwise, I'm looking at our time. We ran later than I was expecting to, but I think this is worth going through all the same. But that is everything for today, and I'll take any questions that you guys have here shortly.